Okay, so for our example today, we're looking at differential equations with kinematics, where velocity is given in terms of x. So my first example today is a particle moves in a straight line with a velocity given by v of x equal to e to the negative x meters per second, where x is greater than 0. If x equals 0 when t equals 0, find the position after 1 minute. Alright, so we want to work out an equation for position. So we are looking at the position, and if we're looking at the position, then we need a rule for x of t. And we want to find the position after a particular time. So I have to somehow get a t back into my equation. We also have an initial condition when x equals 0, t equals 0. So again, all of my variables that we're talking about are x and t. So somehow we have to take this initial expression and get it with x's and t's. And it's really quite simple. The first thing that we need to recognize is that velocity is just equal to the rate of change of position with respect to time. So our velocity is equal to the change in position with respect to time. So I'm going to rewrite that v of x as dx dt. Okay, so velocity is dx dt. Now, if I want to solve this differential equation, the first thing I'm going to need to do is to flip it upside down and write it as 1 over e to the negative x. And because it's a negative power, it's much better to just write that as e to the power of x. And then finally, if I want to find out what t is, I'm going to find the integral of e to the x in terms of x. And to work out my constant of integration, I'm going to substitute in some values here, and I know that the initial x value is 0 and the initial t value is 0. Now, because I'm in terms of x here, I'm going to get my equation in terms of x. Now, I shouldn't use the same x, so I'm just going to put a little 1 there. And my initial x value is 0 and my initial t value is also 0. So by substituting in these values, I'll work out the constant of integration c in one step. So the integral of e to the x is e to the x, and I need to put in my terminals of x1 and 0, and I need a plus 0 on the end. So that gives me t equals e to the power of x1 minus e to the power of 0 plus 0, or t is equal e to the x 1 minus 1. Okay, so now we can rearrange this to get the value for x. So add the 1, take a log. You can see I've sort of got rid of the 1 already because of just habit. I don't know if we really need to put it in there. I just remember that the examiners last year specified that this x in my equation up here isn't the same as this x, so really we shouldn't name them the same thing. But they didn't actually specify that you would lose a mark if you did. So here's my equation for x, and then we want to find the position after 1 minute. So we need to sub in t equals 1. And that gives me log to the base e of 2 equals x. And I've just realised that I've substituted in t equals 1, but my original equation was in meters per second, so I can't substitute in 1 here, can I? My time at 1 minute is equal to 60 seconds. So we need to substitute in t equals 60. Just get rid of that 1 minute in the middle so it's not confusing. So cross that out, and I actually need to say that my x value is at log to the base e of 61, which is approximately 4.11 meters. Okay, that's the end of the example.